Welcome back, Chemistry 30. This is the second part of the 19.3 booklet. I left you with these questions here, B and D, looking for pH of the solutions having the following concentration. So here we have the hydrogen ion concentration, 5.8 times 10 to the minus 11. So easily enough, you just put it into the pH equals negative log of H, concentration of H, and we get 10.2365. We have two sig figs here, so we keep the 10. We could write a decimal after that to ensure that the 0 is a significant digit. And of course, a pH of 10 means it's a basic solution since the pH is greater than 7. Over here, just like this one over here, we have the hydroxide ion concentration. So H times OH gives us 1.0 times 10 to the minus 14. So to solve for H, divide it by 1.3 times 10 to the negative 2, and I get 7.69 times 10 to the minus 13 molar for the concentration of H. Once I've done that initial step, then I can figure out the pH just like I did in part B, and it works out to be 12. Okay, another relationship that we saw earlier on the pH chart versus pOH chart is that when I take any particular pH, add the corresponding OH, I get 14. So we had that. Also, so that was part B here, and also the potency of hydroxide ions, of course, would be the negative log of the concentration of hydroxide. So we have those two new equations. So we could have used this one back over here. If we had the hydroxide ion concentration, figure out the pOH, and then from there the pH would just be whatever number I got there, subtracted from 14. So this likely would have been a little bit easier to use than using the ion product equation. And yes, we had this from earlier as well. Okay, so calculate the pH and the pOH of these. So here, using that new equation, if we have the hydroxide ion concentration, we can figure out the pOH. So negative log of the hydroxide ion concentration, I get 12. And I know that that and the pH must add up to be 14, so there you have that the pH must be 2. Maybe pause the video, you try this one over here. Okay, if you had a chance to do that, first of all, the pOH, the negative log of 1.3 times 10 to the minus 2, you get 1.9. Subtract that from 14, and I get 12.1. Okay. In this part here, what happens if you have the pH and you're asked to find the hydrogen concentration or the hydroxide ion concentration? So there's another, basically taking the inverse log, or the inverse log means 10 to the negative pH. So this is another equation we have, and I'm going to summarize these all at the end of the booklet as well. So 10 to the negative pH, if I know the pH is 5.04, 9.2 times 10 to the minus 6. And then of course figure out the hydroxide ion concentration. I have my ion product, H times OH equals 1.0 times 10 to the minus 14. So divided by my H, and I get 1.10 times 10 to the minus 9 molar for hydroxide. So maybe pause the video, you try this side, same type of calculation. Okay, if you had a chance to do that, I didn't go through all the math here, I just worked it out and put the final answers down. So 10 to the negative 13.44, we get 3.631 times 10 to the minus 14, and then rearrange the water constant equation, and we would get hydroxide equal to 0.2754 molar. Okay, the last couple of things we'll be looking at strong acids and bases and weak acids and bases. So for strong acids, first of all, we assume that 100% dissociation occurs. So if I have HCl, 100% of it breaks down into H plus ions and Cl minus ion solutions. So here, just simply calculate the pH. Now, if we have a strong acid here, HCl, of course it breaks down into H plus and Cl minus. Over here I'd have nitric acid that breaks down into H plus and NO3 minus. So what we excuse me, how we could view this as, initially we have this much acid. 0 hydrogen ions, 0 chloride ions. And of course shifting happens at equilibrium. We assume, yes, all of the HCl gets used up to make hydrogen ion concentrations, hydrogen ions, and chloride ions. Now these are all 1:1:1 ratios. So 2.6 produces 2.6 and 2.6. If this had been a 2, it would be double that number, because each acid would have 2 hydrogens, so this would be double. But I just used 1:1 here. In this hand-in assignment that you're going to be doing, I have a couple of 2:1 ratios. I may even have a 3:1 ratio. So at equilibrium, all my H pluses, my concentration of hydrogen is 2.6 times 10 to the minus 2. So we just simply calculate the pH of that. That's it. That's all there is to it. If I look over here, and I would tell you, of course, whether it's a strong acid or a strong base. This is a strong base, sodium hydroxide, so it breaks down to NaOH breaks down to Na plus and OH minus. So initially, if I had 7.5 times 10 to the minus 3, that breaks down and makes 7.5 times 10 to the minus 3, because it's a 1:1 ratio. So I have my hydroxide ion concentration at equilibrium. So what I could do to figure out the hydrogen ion concentration is use this equation, or I could figure out the POH and then subtract that number from 14 to get the pH. So there's more than one way to do it. In fact, a little schematic that I have here is this, that you may want to copy out on, I think I have on the last page, I have the formulas, but you may want to copy out this somewhere, the relationship between pH, H, OH, and POH. So pH going to H, 10 to the negative pH. Hydrogen ion concentration is going to pH, of course that's the negative log. And similarly over here with the POH going to hydroxide ion concentration, we had this idea. To go from hydroxide ion concentration to POH, we had that. The relationship between pH and POH, and the relationship between H and OH. So over there, if I know what OH is, I could go, and I want to figure what pH is, use this equation, then do this. Or I could, again, find out the POH, and then use this relationship to figure out pH. So you can see there's two different routes you can take. It doesn't matter which one you use. Okay, so this one I chose to use this one. So hydroxide ion concentration is 7.5 times 10 to the minus 3. Rearrange, solve for H, I get 1.33 times 10 to the minus 12. And then, of course, to figure out the pH, take the negative log of that, and I get my result of 12. Okay, so what I'll do is I'll have you do the ones on the right-hand side. So again, we have a strong acid here, and this one here is a strong base. So follow the format and see how you make out. Okay, we'll see you soon.